Hello GCSE computing students, Mr. Holmes here with another video. This one deals with characters, and in particular it deals with character sets and the standard ASCII character set. So without further ado, let's get into it. Alright, before we carry on, you need to understand this basic principle of the von Neumann computer model. That you should remember that computers are devices that take in inputs, process those inputs, which they may store temporarily in primary memory or RAM, or long-term on secondary storage, and then produce as a result some sort of output. Now let's think about this a bit more carefully. All the processing and storage that takes place inside the computer actually takes place in a digital format, and you can see that is represented by the square waveform, because what's going on here is that all the signals that are coming into the computer are being translated into a series of zeros or ones equivalently. The zero represents a low state of electricity or an off state, and the one represents a high or an on state. These off and on states are used to drive very tiny electronic components called transistors, and they're like little microscopic switches that are themselves controlled by electricity. And these transistors, by using whatever comes into them, either turn their inputs on or off. If the input is turned on, we represent this by a 1. If the output is turned off, we represent this by a 0. This is called binary because there are only two states, 0 or 1, on or off. However, this is not the case with the actual inputs that come in, nor is it the case with the outputs come out. The inputs and outputs are actually devices that interact with us in the real world. It is a mouse, a keyboard that we physically move around or touch. And it's that real world interaction, those touches, that get translated by the hardware it gets digitized into a sequence of ones and zeros. So even pressing an A on a keyboard is digitized or turned into a sequence of ones and zeros. Likewise, for the output, any output coming out of the computer system is simply that digital representation of ones and zeros turned into something that we can see or interact with in the real world. For example, by turning a sequence, a pattern of pixels on the screen on and off, so that it displays the character A, for instance. On the GCSE Bite-Size website, you can find the following diagram. Now this diagram is quite good in that it helps explain a great deal of what I'm trying to explain. So let's get into what you need to understand from this process. So referring back to our von Neumann computer model, we are taking an input, which is going to be pressing a key on the keyboard, and that's going to be turned into some sort of digital representation that the computer understands. So you might ask, well, how is this done? The answer is that this is done by using a lookup table, a set of characters, a set of codes. So the keyboard in this instance is nothing more than a giant switchboard. When I press the A key down, it closes a switch, and the character code, the ASCII character code of 01000001, or the decimal equivalent of 65, is sent into the computer. The computer doesn't know I've pressed the character A, it just knows I've pressed the ASCII character number 65. How does the computer know that this represents an A? Well, this has been predefined as a standard, so that computers all over the world, if they talk standard ASCII, know that the binary value of 65 represents the character capital A. The computer itself has no knowledge or understanding of what capital A means. It just knows that, hey, you pressed a character that represents 65 on the ASCII table. This is how I display it on the screen, and I can then answer questions about it, like it comes before B, in capital B, in the ASCII character set. Conversely, your screen doesn't know anything about the alphabet. All it knows is that, oh, I have to display the ASCII value of 65. And I know that I need to look it up against in my font set, and this is what 65 is represented as on the screen. And I will turn these series of pixels in this pattern on and off, and this will represent a capital A, and bing, capital A will appear on the screen. Right, so there are a number of important definitions you have to learn, and here they are. The first one is, what is a character? Well, a character is a single alphanumeric symbol. Alphanumeric comes from the word alpha, as in alphabet, which means a letter, and numeric comes from the word number. So an alphanumeric is some symbol that represents either a number or a letter. Okay, so what do I mean by a symbol? It means that it's something that can be drawn or represented graphically. So, for instance, if I'm talking about the character A, I would mean some sort of representation that capital A would look something like that. The figure which I've just drawn is a symbol. It represents the character capital A. Now, the way I've drawn it may be very different from the way you would handwrite it, and that's what makes it interesting. This is how we end up with different fonts on computers, but that's a discussion for another matter. The next most important definition you need to be able to understand and explain is, what do I mean by a character set? So a character set, one definition, is a group of characters, so not just one, but many of them, that the computer recognizes in their binary representation. So this means the computer knows that when it gets the value of 65, it knows that it represents a capital A if we are talking standard ASCII. Standard ASCII is one of the many character sets that computers use. Another definition is, what is a character? What is it? This should be, what is a character set? Apologies. Another definition is a list of characters and their associated binary codes recognized by the computer's hardware and software. Remember, we need a combination of both hardware and software oftentimes to make this work. What is a character set again? Got that mistyped. A character set is a particular mapping between a character and its byte string. What do I mean by that? There's the character representation for A. The byte string is this 8-bit. A bit is a binary digit. A string of 8 ones and zeros, having a unique representation for that particular character. Now, when computers started off in their early days, the Americans had a lot to do with it, and hence they came up with the ASCII standard interface. And in those days, computers used to use 7 bits to represent all their data. ASCII stands for American Standard Code for Information Interchange. And the designers of computers back then realized that if they were going to get computers to communicate with each other, or to have any sort of ability to move files from one computer system to another, then those computers had to use the same code system. Otherwise it wouldn't work. And so they came up with this standard. To understand how this works, you need to have a little bit of an understanding of how binary works. So we'll do a quick run through of that. In binary, each bit or binary digit represents a 1 or 0. But just like the decimal number system, where we start with units and then go up in tens, the binary system works in a similar way, but we go up in powers of 2, factors of 2 instead of going up by 10. So starting at 1, I go from right to left. I can number these columns and give them values, and I simply double the value prior to the one on the right. So the column on the left gets the value twice the value on the right. So B2, the second bit, will get the value of 2 times 1, which is 2. The next bit will get the value of 2 times 2, or 4. And then we would go up to 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, and finally 32 times 2 is 64. So those would be the bit value positions of bits 7 to 1. Now, what is incredibly clever about how they did the ASCII table is they took these high order bits and used them to break the codes up into sections that made sense. So the lowest, you can see that everything that started with 0, 0, all the codes that start with 0, 0 are all control bits. And the first code that we actually hit, that is what we call a printable character, is the space, which is 32. And that has the value 0, 1 in binary. And there we go, that would represent 32. And so 30, oopsie, dyslexia strikes again. 32 is the character representation for space. It's the first non-zero starting binary value. They then went on and were quite clever about how they did the rest of this. The ASCII character that represents, or the code value that represents the character 0, the symbol 0, is the ASCII code 48 dead. 48 is 0 in the high order bit, turning 32 on and 16 on, and that's it. That gives us 48. So that is the first ASCII code that you really should try and commit to memory. It's 48 is the ASCII code for 0. But they didn't just put everything else in randomly. You can see 49, the code for 49, which follows, is going to be the character code for 1, which is simply adding 1 onto that ASCII value there. And that'll give us the character code for the ASCII symbol 1, which is in fact 49. The character code for 2 is 50. The character code 2 would be 50, and 3 is 51, and so on and so forth. I mean, banging on about capital A being 65. The printable letters of the alphabet all start with a, the most significant bit starts with a 1. And then we put in 0, 0, 0, 0, 0, and then they took a 1. That's completely symmetrical. But they said, right, so that's going to be capital A. B would simply be the next one up, which would be that. So B, capital B, would be the ASCII character code 66. C would be that one there, which would be 67, and so on and so forth. And then they were even cleverer, because they then lined up capital A and little a. The only difference, if you look at the binary codes, the only difference is that instead of starting with a 1, 0, the lowercase letters start with 1, 1. But the lower end of the ASCII bit, those 4 bits of that ASCII table for little a, so those codes there for little a and capital A are identical. For B and little b are identical. The only thing that changes, the difference is that the higher order bits for the capital letters start with 1, 0, and the higher order bits for the lowercase letters start with 1, 1. So to summarize, the only codes you really need to learn are these 3, namely that so that 0 is in fact the ASCII character number 48. You should learn that one. That capital A is 65 and little a is 97, and the rest can be worked out because they all follow sequentially. I hope this has given you a better understanding of what standard ASCII is about. The final thing to talk about is that, to remind you that standard ASCII only uses 7 bits. It is a 7-bit code, which means it can represent 2 times 2 times 2 times 2 times 2 7 times, or if you like, 2 to the power of 7, which I can write in computerese as follows: 2 to the power of 7, which gives me 128 unique characters that the standard ASCII character set can represent. Now, that is great for languages like English alone, but when we start talking about other Latin-based languages, European languages, and not even to mention Oriental or Eastern languages, where we don't even use the Latin alphabet, we then are in serious trouble. And this is why the extended ASCII character set and ultimately Unicode was developed. So ASCII, great if you speak English, not so good if you don't. But the way it was constructed and put together is really clever. It's an ingenious character set. It only needs 7 bits to represent all the characters in the English alphabet, as well as many of the punctuation symbols. And remember, each code uniquely has a unique binary value that is predefined, so that we have a standard across all different computer platforms, so that if my computer is talking standard ASCII and your computer is talking standard ASCII, we can communicate and our files will have the same meaning. So if it sees the binary value of 10000001, it knows that it's the ASCII character 65, and it knows that it represents the character capital A. That's all for now. I hope this gives you a really good understanding of ASCII, what character sets are, and what the standard ASCII character set is. Thanks for watching. Mr. Holmes signing out.